Listen to me. Go find a mirror. Look at it. What do you see? You see your own nose. You see the wall behind you. And you think you know how that image gets there, don't you? You have this comfortable little picture in your head from high school physics. You imagine light acting like a polite little billiard ball. It leaves your nose, travels in a perfect straight line, hits the glass, bounces off at the exact same angle it came in. Angle of incidence equals angle of reflection, and pop right into your eye. It feels intuitive, it feels logical, it feels safe. Well, I am here to tell you that this picture is a lie. It is a complete fabrication. It is wrong. That is not what light does, not even close. If you think light travels in a straight line, you are living in a biological hallucination. The reality of what is happening on that mirror's surface is so much stranger, so much more chaotic, and so terrifyingly beautiful that your brain filters it out just to keep you sane. Light doesn't bounce like a ball. It behaves like a sniffing dog that has lost its mind. It explores every single inch of that mirror. It hits the left edge, the right edge, the top, the bottom. It explores paths that go to the ceiling. First, paths that loop around Mars, paths that shouldn't exist. You don't see them, but they are there. And the only reason you see that reflection in the middle is because of a massive, silent conspiracy of mathematical cancellations happening right under your nose. Let's tear this down. You talk about a ray of light. You draw a line on a piece of paper with a ruler. That line represents the path of least time, the quickest way from A to B. We call it Fermat's principle. And it works perfectly for designing telescopes and eyeglasses. But ask yourself, how does the photon know? How does a mindless particle of light leaving your nose know beforehand which path is the fastest? Does it have a map? Does it have a GPS? Does it calculate the derivative of the distance function as it flies? Of course not. That is absurd. The idea that light chooses the straight path is a philosophical disaster. It implies the photon has agency, or that it can see the future. If we want to understand reality, the real reality, the one underneath the fabric, we have to stop drawing lines with ruler. We have to stop thinking of light as a traveler moving on a highway. There is no highway. There is no speed limit sign that says straight lines only. When you strip away the ruler, when you strip away the lens, what you are left with is a quantum event. And in quantum mechanics, unless you catch the particle in the act, it does everything it is mathematically possible to do. It doesn't choose one path. It takes all of them simultaneously. I want you to try something. It is a mental experiment. Close your eyes for a second. Now imagine a single photon, a single particle of light, leaving a source, say, a laser pointer, and heading toward a detector. In your mind, you see a little glowing bullets zipping through the dark, right? A little tracer round. Now, stop, rewind. That image, that glowing bullet, that is your brain lying to you. You are visual creatures. You evolved to throw spears and catch apples. Your brain is hardwired to model the world as solid objects moving on continuous trajectories. It is a survival mechanism, a simulation program running in your parietal lobe. But a photon is not a bullet. It has no continuous trajectory. If you put a detector anywhere between the source and the screen, yes, you will find it. Click, it is there. But if you don't look, if you don't measure it, it is not somewhere, it is everywhere. It is a probability, amplitude. It is a ghost. I want you to feel the discomfort of that. Try to imagine something that has a start point and an end point, but no specific path in between. It feels like a gap in your mind, doesn't it? Like a glitch in a video game. That glitch is where quantum mechanics lives. We are going to exploit that glitch. We aren't going to fix it. We are going to dive into it. We are going to replace your bullet with something much more powerful, a stopwatch. So if we can't say the light is here or the light is there, what can we do? We are physicists. We measure things. We need a new tool We need to stop asking, what is the light doing? Because that question has no answer. Instead, we ask, what is the probability that the light will arrive at point B? To answer this, we have to adopt a new rulebook. It is called the path integral, or the sum over histories. But I have a translation for you. I call it the stopwatch and the arrow. Forget waves for a moment. Forget particles. Here is the operational definition of reality. Imagine that every single photon carries a tiny, imaginary stopwatch. This stopwatch has a single hand that spins, and it spins fast, incredibly fast. For red light, it spins roughly 400 trillion times per second. That is the frequency of the light. Now here is the rule, as long as the photon is moving. The stopwatch hand rotates. The moment the photon hits the detector, or your eye, the stopwatch freezes. We look at where the hand is pointing, say 3 o'clock or 9 o'clock. We draw an arrow in that direction. That arrow is the probability amplitude. The length of the arrow is squared to get the probability of the event happening. This is the machine code of the universe, not waves, not particles, rotating arrows. You might be thinking, okay, Feynman, so the photon carries a stopwatch while it travels through space. Number, stop, right there. You are still thinking of space as a container, a stage where the actor performs. You think the path exists, waiting for the photon to walk on it. That is the container fallacy. The path is not a pre-existing tube. The path is defined by the event itself. When we say light explores all paths, we don't mean it sends out little scouts. We mean that the calculation of reality requires us to account for every possible space-time geometry connecting point A and point B. If I block a path, the reality changes. If I open a slit, the reality changes. The photon isn't an object moving through a static background. The photon and the path are coupled. The arrow I told you to draw, it represents the contribution of a specific history. If the path is longer, it takes more time. If it takes more time, the stopwatch rotates more. If it rotates more, the final arrow points in a different direction. The geometry of the universe dictates the rotation of the stopwatch. Space isn't a container, it is the clockmaker. Let's visualize this on the mirror. This is the core of everything, so listen closely. Imagine a light source at S, a mirror in the middle, and a detector at P. We want to know how light gets from S to P by bouncing off the mirror. Classic physics says it hits the middle where the angles are equal. But quantum mechanics says, consider a path that hits the far left edge of the mirror. Consider a path that hits the far right edge. Consider a path that hits just slightly to the left of the center. Now, look at the stopwatches. The path to the far left is long. The light has to go all the way out and come all the way back. It takes a long time. The stopwatch spins, spins, spins. Maybe it makes 10 million and a half turns. It stops at 6 o'clock. Now look at a path right next to it, slightly less to the left. It is a slightly shorter path. The time is slightly less. The stopwatch spins a little less. It stops at 5 o'clock. Move a bit more. 4 o'clock. Because the paths at the edge are very different in length. The hypotenuse changes rapidly as you move away from the center. The time differences are large. The stopwatch arrows point in all random directions. 6 o'clock, 5 o'clock, 2 o'clock, 9 o'clock. Now, here is the magic. What happens in the middle? In the middle of the mirror, the path is the shortest possible path. But more importantly, if you move slightly to the left or slightly to the right of the center, the path length hardly changes at all. It is the bottom of the curve. The time is almost exactly the same. So the stopwatches for all the paths in the middle stop at almost the same time. They all point at roughly 12 o'clock. Now, the grand addition. We have millions of arrows from millions of paths. We have to add them up. How do you add arrows? You put the tail of the second arrow at the head of the first one. You make a chain, a snake. Look at the arrows from the edges of the mirror. One points up, the next points left, the next points down. When you connect them, they form a tight little coil. They spiral around in a circle and go nowhere. The net distance from the start to the end is zero. They cancel each other out. The light did go there, but the probability amplitude sums to zero. It is a ghost town. But look at the middle. All those arrows are pointing roughly the same way. 12:01分 11:59分 When you connect them head to tail, they don't coil. They form a long, straight line. They boom out. They reinforce each other. The final probability, arrow, is huge. This is why you see the reflection in the middle. It is not because light chose that path. It is because that is the only place where the stopwatches didn't kill each other. The straight line of classical physics is just the place where the quantum phases happen to line up. It is a statistical emergence, not a fundamental law. You might not believe me. You might say, Feynman, this is just a fancy mathematical trick. The light really just hits the middle. Oh, really? Let me prove to you that the light is hitting the edges. What if I went to that mirror and I scraped away the glass in specific spots? What if I calculated exactly where the arrows point left, and I painted over those spots with black paint, and I kept only the spots where the arrows point, right? If I do that, I am removing the arrows that cancel out. I am removing the interference. And do you know what happens? The edge of the mirror suddenly starts to reflect. You can construct a mirror that reflects light at the wrong angle, just by blocking the paths that would normally cancel it out. We call this a diffraction grating. You see these on the back of a Beetle or on a CD-ROM. That rainbow color, that is the proof that light was trying to go everywhere. By meticulously destroying the cancellation, we reveal the hidden chaos. We reveal that the light was always there, lurking in the shadows, waiting for the destructive interference to be removed. The universe is a messy, chaotic riot of paths, and order is just what is left over when the chaos cancels itself out. This leads us to something even more disturbing: simultaneity. You have this feeling that the reflection happens now. But think about the stopwatch again. The path to the edge of the mirror is longer. It takes more time. The light that travels via the edge arrives later than the light that travels via the center. Yet, in the quantum calculation, we sum them all up together to get the event photon detector. From the perspective of the quantum sum, time is just another coordinate. The photon is not a distinct particle moving through time. It is a smear of history. The event of reflection is constructed from contributions that happened at different times. The now you perceive is a collapse of a four-dimensional structure into a three-dimensional slice. The interference pattern, the reality of the reflection, depends on the relationship between these different times. If you change the timing by moving the mirror, you change the picture. There is no universal snap of the fingers where the universe updates. There is only the accumulation of phases, the winding of the clocks. Take a step back, way back. Look at the whole diagram. The source, the mirror, the eye, and all those millions of squiggly paths. In your mind, you play it like a movie, but the math doesn't play like a movie. The math treats the entire history of the photon as a single, static object. The path integral is an integral over all possible histories. It is as if the universe is a block of bread, and we are slicing it. The photon's journey is not a sequence of decisions. It is a geometric feature of the space-time block. The reason the light seems to travel in a straight line is because the geometry of space-time makes that particular path the stationary phase, the path where small variations don't change the action. But the other paths, the crazy loops, they exist in the math just as much as the straight one. They are real. They are part of the structure. The universe is not happening. It is. The reflection is a static jewel of probability amplitudes, crystallized in space-time. And your consciousness is just crawling along the timeline, discovering it. I know. This makes you feel small. It makes you feel like a cog in a machine, like everything is pre-calculated. If the light just follows the path of stationary phase, is there any room for freedom? Is there any room for surprise? But look closer. The classical world, the world of straight lines and billiard balls, that is the world of determinism. That is the boring world. The quantum world, the world of the stopwatches, is probabilistic. The final arrow gives us a probability, not a certainty. Nature, at her heart, is unpredictable. We can calculate the odds with staggering precision. Kidd is the most precise theory in the history of science, but we cannot predict the individual event. The straight line is just the most likely outcome of a democratic vote held by billions of possible paths. You are not living in a rigid clockwork universe. You are living in a universe that is constantly gambling, constantly exploring every infinite possibility. And what you see as reality is just the casino's house, edge winning out over the long run. Why is this so hard to understand? Why does your brain hurt? Because we are monkeys with car keys. Our language, English, Chinese, French, was invented to tell each other where the fruit is or who is hiding in the bushes. It was not invented to describe the behavior of hyperdimensional, complex numbers in Hilbert space. When I say stopwatch, I am lying. When I say arrow, I am lying. These are just translation schemes. They are metaphors to help your primate brain grasp a reality that is fundamentally alien to your intuition. The math is the only true language. The complex number, psi, the integral, e, eyes. That is the truth. Everything else I tell you is a bedtime story, but it is a necessary story. Because without these stories, without these stopwatches, we are blind. We are trying to navigate a quantum universe with a classical map. The map is wrong, but it is the only one we have that fits in our pockets. So, look at the mirror again. Don't look at your nose. Look at the glass. Look at the light. Realize that what you are seeing is a miracle of cancellation. You are seeing the survivor of a billion-path cage match. The light didn't just bounce, it danced. It danced across the entire universe, swirling and spinning its internal clocks, exploring every absurdity, every impossible loop, just to land in your pupil and create that image. The world is not solid. It is not simple. It is a shimmering, vibrating web of infinite possibilities, held together by the fragile mathematics of interference. And the fact that you, a collection of atoms, can stand there and understand this, that you can hold the universe's stopwatch in your mind, that is the strangest path of all. Keep looking, keep wondering. Nature is far more imaginative than we are.